Guys, today I'll be teaching you about centrality measures in a network. So before starting, this notes using the book by Newman, Network and Introduction by MEJ Newman. So if you have any further doubts, you may refer to this centrality measure. What centrality measure is? It is a mathematical measure that captures interesting features of network structure quantitatively for easy understanding. Right? A network, let's say this is the network, but how do we know which node is important to me, which node is the least important to me? We find the importance, or how we quantitatively decide which node is important to us, using something known as centrality measures. Let's take an real life example. Let's say you want to know who is the who is basically the most important person in a country. Let's say you don't know anything about the country. Let's suppose the country is Finland. I personally don't know who is the most famous celebrity of that country, or who is the prime minister of the country. I have no idea. So I'd probably go to Instagram and then take out the data of the most followed person of that country. So I can say that the person who is most followed is the most influential person of the country, right? So this is a very basic idea, and this is known as degree centrality, right? So we say that the node that has the most number of neighbors is the most important node. Okay, this is a very basic idea. In this network, we can say that this node, this is connected by 1 2 3 4 5 6. This node is connected to 6 nodes, and we can say this is the most important node of this network, right? Or we can say this one is the most important node. It is connected to but 5 nodes, so it is less important than this node. Degree centrality, aka degree, it is the simplest form of centrality. Number of edges connected to the node is the degree centrality, both in degree and out degree considered in case of directed graph. We have a node, right? This is connected to, let's say, 3 other nodes. Okay, this is network 1, right? And this is network 2. These are the 2 nodes that we are gonna consider, right? So right now what we are having is something known as degree centrality. Degree centrality is just the number of connected nodes. So looking at this, you will say that yeah, this is the important node, it has degree equal to 3, and then you'll go to this network. Here also degree is 3. But are these both nodes equally important in the network? It has, network 1 has total 4 nodes, and this node is connected to 3 out of all those 4 nodes. But this network has total of, this has total of 9 nodes, and it is connected to only 3 of those. So if you see percentage wise, this is more important, right? So just using degree centrality is not a very good idea. Hence what we do is we normalize it if we want to compare two graphs. We take the degree and we divide by all the possible degrees. Okay, so this is how we normalize a degree. So this is important, since same degree of 2 nodes in 2 different networks doesn't mean they are equally important. So let's say if there are 10 nodes and a node has degree 10, it is more important. But let's say another node also has degree 10, but total number of nodes is 10,000. So obviously the node in the first graph is much more important. So hence that is why we use degree centrality, right?